Alright, in this video we're going to see how to graph an exponential function. It's all about making a table of values. So let's get that ready. We're going to start with the parent function, which will not include the negative 3. So I'm going to ignore the negative 3 just for a minute. So because we're starting with the parent function, we can always start with the x values, negative 2, negative 1, 0, 1, and 2. And we just need to find the y values that go with these x values. For now, we're not dealing with the 2 either. Alright, so we're just doing 1/4 to the x power. You'll see what I do with the 2 in a minute. In fact, the bottom line is going to be, because we have an a value, you know we're going to need a third column, but that comes in a minute. So 1/4 to these powers. So okay, so you understand I'm doing 1/4 squared and 1/4 to the 1 power and 1/4 to the 0 power, and then 1/4 to the negative 1 power and 1/4 to the negative 2 power. Alright, starting down here at the bottom, 1/4 squared is just going to be 1/16. Right? I'm just squaring the numerator and the denominator. By the way, I apologize for the sound of my voice. I'm pretty sick, so I have a range of 2 notes, this and this. That's it. So I apologize for the sort of monotone, sleepy, near-death sound in my voice. So obviously 1/4 to the 1 power is just going to be 1/4. Anything to the 0 power is 1. Alright, so that was pretty easy. As a shortcut for these other two, they're just going to be the reciprocals of these. So if this is 1/4, shortcut, this is going to be 4. And this is going to be 16. Okay, so great. Now it's time for the third column, and we do the third column when we have an a value, a number that's being multiplied in the front. And so the third column will, I don't know why, I guess I said, because I said third column I put a 3, but the a value is 2. So what I do is I will multiply by 2 because that's what's happening. So I'm going to do 2 times these y values. Alright, so that's going to make this become 32 and 8 and 2. 2 times 1/4 is 1/2. This will be 1/8. If you need to see more on the 2 times 1/4, alright, that's like 2/1. So multiplying straight across, that gives me 2/4, which reduces to 1/2. Once you have the the third column, you can disregard the middle. I apologize. Now, I'm going to plot these points, but this is not my final answer. Remember, there's really a -3 here, and that's going to cause a shift. When we're inside the function, adding and subtracting causes a shift that's to the left or to the right. But remember, this is the one where it's the opposite of the way it looks. So -3 is actually going to be a shift to the right by 3. To the right by 3. So we're going to need to take each one of these points and shift them right 3. So we'll have these points. So these points will show us our final answer. Understand that we have a horizontal asymptote here. So as you sketch your curve, make sure that you do not cross the asymptote. And in fact, on the right hand side, it's going to appear to trace the asymptote, even though in your mind you know that it doesn't actually ever touch the asymptote. So in the end, your graph should look very much like this. Alright, as far as type, of course this is exponential. And more specifically, see how it's decreasing from left to right. So this is exponential decay. If it were increasing, it would be growth. Now the domain, it goes left forever and right forever. So that's negative infinity to positive infinity. Now the range is always from bottom to top, the y values. The asymptote is like a floor. So it goes from 0 to infinity. Alright, you can't reach the asymptote, so we have to leave this a round parenthesis. The horizontal asymptote is y equals 0, the x-axis. Don't just put 0, put y equals 0. Now the y-intercept is what you get when you let x equal 0, because on the y-intercept is where the graph reaches the y-axis, but on the y-axis, x is always 0. So basically, let's substitute in 0 for x and see what we get. So if we do that, then we'll have 2 times 1/4 to the negative 3 power. Right? If we put in 0 for x, then that just leaves a negative 3. Now, a negative power, you do the reciprocal. So this will become the same thing as 2 times 4 to the third power. Do not multiply these and get 8. All right, order of operations. You have to do 4 to the third power. So this will be 64. So 2 times 64 is 128. So this is going to give me the y-intercept. It will be 0, 128. Now as far as the transformations, compared to the parent function, we already talked about we have a shift to the right 3. But also this a value is a vertical stretch by a factor of 2. And so that's how you graph an exponential function. Let's look at another example. Again, we will make a table of values. And there is an a value, so eventually I will need 3 columns. So again, we'll use -2, -1, 0, 1, and 2. Now, the parent function is just this part right here, 2 to the x power. So that's why when I find my initial values, I'm just doing 2 to the -2 power, 2 to the -1 power, 2 to the 0 power, 2 to the 1 power, and 2 squared. So this is going to give me 4 and 2. Anything to the 0 power is 1. And then these are always going to be reciprocals of these. So this will be 1/2, and this will be 1/4. Alright, now, because there's an a value, we need a third column. And this is where we multiply by the a value. So I'm going to do 1/2 times each of these. So that's going to give me 1/8, 1/4, 1/2, 1, and 2. Okay, once we have the third column, we can forget about the middle column. So we're going to plot these points. But these points are not the final answer. This is just the skeleton. We will have to go back and deal with the -1 and the 4. But those will be horizontal and vertical shifts, translations. So we'll do that afterwards. So let's graph the skeleton. Okay, so we have -2, 1/8 is very close to 0. -1, 1/4 is just up a little bit above that. 0, 1/2 is right in the middle. 1, 1, and 2, 2. Alright, so we have these 5 points. Alright, here's a closer look. Now, let's talk about the transformations, these two translations. Now this -1 right here, this is going to be a horizontal change, and these are always the opposite of the way they look, so this will actually be to the right by 1. And when you're adding or subtracting on the very end like this is vertical, so, and this is more normal, so +4 will be up 4. So we need to shift everything right 1 and up 4. So that's what we're going to do. We're going to move each of these points right 1 and up 4. Okay, so if I go right 1 and up 4, that point's going to be there, and this one's going to be just up a tiny bit, and then we have that one, and then that one, and then that one. So I've moved each of these points right 1 and up 4. So these points will show me the final answer. Now notice the asymptote, which normally starts out at the x-axis, because we had a vertical shift up 4, that's going to move the asymptote as well. Alright, so there's your asymptote. So as we draw this graph, it should be approaching the asymptote. Now we know that the points never actually reach the asymptote, but it's going to look like they do on a graph. So as you draw it, on the left side, you're going to wind up tracing the asymptote. But in your mind, know that it doesn't really touch. So in the end, your graph should look something like this. So this was another graph of exponential growth. We can tell from the equation when it will be growth increasing or decay decreasing based on this value. If this base is bigger than 1, then that's when it's going to be growth. If this were something between 0 and 1, so we're not talking about a negative number, but something like 1/2 or 1/3 or 0.4, that's when it's going to be decreasing. That's when it will be decay. The domain, again, it goes left forever and right forever, so that's going to be -infinity to +infinity. The range is the y value, so that's bottom to top. The asymptote acts as a floor here at 4. So the range is going to be from 4 to infinity. Alright, we'll use a parenthesis at the 4 to show that we don't ever actually reach the 4. So it can't be included. The horizontal asymptote is y equals 4. Don't just put 4, put y equals 4. The y-intercept is where the graph touches the y-axis. We can see it here. We can always get it by substituting 0 for x and then evaluating, but we don't have to do that this time. The original point before we did this shifting, the point that is now the y-intercept, let's take a closer look. Alright, the point that is now the y-intercept is the second point here. And that came from this point right here. Now, so that point was -1/4. Okay, but it shifted and became the y-intercept. But we know that it is 1/4 units above the asymptote. So this is 4 1/4. Okay, it's just a fourth above the 4. So we know it's 4 1/4, which is 4.25. So the y-intercept will be 0, 4.25. Now you could also get it by letting x be 0. So let's take a look at that. You can always get the y-intercept by substituting 0 for x. So that would give us, hold on, let me make this smaller. Substituting 0 for x gives us 1/2 times 2 to the negative 1 power, and then plus 4. Alright, the x is gone because it's 0. Negative 1 power does a reciprocal, so this makes 1/2 times 1/2. Well, 1/2 times 1/2 is 1/4. Alright, so there's your 4 and 1/4 right there. So there's your 4.25. Okay. Alright, so there are 3 transformations to write. The 1/2 is a vertical compression by a factor of 1/2. Alright, because of the way it's less than 1. And it was also right 1 and up 4. So those are the transformations. So that's it for number 32. Now for the rest of these, we're not going to actually graph them. If we need to make a little sketch on scratch paper, we'll go to the black screen. But we're just going to answer these questions. So look, these are all exponential functions. So the domain for all of them will be the same. These graphs are all going to go to the left forever and to the right forever. So all of the domains will be negative infinity to positive infinity. Alright, now let's talk about the range. A graph would, an exponential function would normally have an asymptote at 0, the x-axis. So pay attention to whether or not there's a vertical shift. So in this case, there's a vertical shift at -2. That means the graph is being shifted down 2. So normally the graph might be doing this and approaching 0. Notice I made it decreasing because I see the base is 1/2. So because of the way that's less than 1, I know it's going to be decreasing. But anyway, this -2 is going to shift the whole thing down 2. So instead of having an asymptote at 0, I know I'm going to have a new asymptote down here at -2. Alright, so I'll have a new asymptote happening. So for that reason, instead of doing this, the graph will do this and approach that. So looking at the green now, the range is going to be from -2 to infinity. Okay, of course the horizontal asymptote is y equals -2, as we discussed. For the y-intercept, you let x equal 0. So if I let x equal 0 right now, that's going to give me, let's see, 1/2, x is gone, so, and that would be to the 1 power minus 2, so I can disregard the 1. So it's just 1/2 minus 2. Well, 1/2 minus 2, I could look at this as 2 over 1. Okay, and I could make like denominators, and by making this 4 over 2. So 1 over 2 minus 4 over 2 is -3 over 2. So this is going to give me the y-intercept. Is going to be 0, -3 over 2. And the transformations are left 1 and down 2. Obviously the down 2 is right here, and because of the plus 1 in the exponent, that's going to be a shift left 1. Alright, looking at number 34, there is no vertical shift. But notice this negative sign in front. That has the effect of giving us a reflection over the x-axis. So while we're at it, we might as well write down those transformations. So reflection over the x-axis, and also left 3 because of the plus 3. So let's draw a quick sketch of this. If it's reflected over the x-axis, normally the graph would be doing one of these. Notice I made it increasing because I'm looking at the 4, and that base is bigger than 1, not including the negative sign. But because of the negative sign, it's going to be reflected over the x-axis. So it's going to be doing like this. Alright, so instead of being 0 to infinity, the range will be negative infinity to 0. Okay, the horizontal asymptote is still y equals 0. Now for the y-intercept, we will let x equals 0. So if I let x equal 0 here, that's going to give me negative 4 to the third power. Okay, so you do this first. 4 to the third power is 64, so that's going to be negative 64. So that's why the y-intercept would be 0, comma, negative 64. Alright, looking at this last one, the negative x causes this to be the reciprocal, so this would be the same thing as 5 times 1/3 to the x power. Now as far as the range goes, nothing is happening. It's not going left or right. It's not going up or down. We have a vertical stretch here. I guess we might as well write that down. Okay, so we have that. Now this is a decay, exponential decay, because of the 1/3. So let's take a look. So it's just doing this type of thing, but the asymptote is still at 0, so the range is going to be 0 to infinity still. Alright, still have y equals 0 happening. Now, the y-intercept is what you get when you put 0 in for x. So this would be like having 5 times 1/3 to the 0 power. Anything to the 0 power is 1. So this will be 5 times 1, which of course is just 5. So the y-intercept would be 0, comma 5.